This will be for the con assignment, interpret two-way tables. The two-way frequency table below shows data on having a curfew on school nights and having assigned chores at home for the students in Alejandro's class. Okay, so they have a total for the columns and they have a total for the rows. Which of the following statements is true about Alejandro's class? The majority of the students have a curfew. Well, let's see. How many have a curfew? 16 out of 34 have a curfew. But as far as do not have a curfew, 18 out of 34 do not have a curfew. So more of them do not have a curfew. Okay? So that means A is not true. Okay? So it's not answer A. Answer B. If a student has a curfew, it is most likely that they have chores. Let's see. If a student has a curfew, so we're dealing with this row only. If a student has a curfew, it is more likely that he or she has chores, okay? Because 12 out of 16 have chores and 4 out of 16 don't. So that's true. If a student has a curfew, he or she is more likely to have chores. If a student has a curfew, it is most likely that they have chores. That's true, okay? If you don't want to risk it, I would check your other answers as well, just in case. All right, so I knew B was correct, but just in case, let's see. More than half of the students do not have chores and do not have a curfew. Well, let's see. Do not have chores and do not have a curfew. That's going to be 10 out of 34. 10 over 34 is not more than half. That's less than half. And just checking answer D. If a student does not have chores, it is most likely that they have a curfew. Okay? If the student does not have chores, this column right here, it's most likely that they do not have a curfew because that'll be 10 out of 14 instead of 4 out of 14. So D is also incorrect. Most of these you don't really need to read. Okay, a survey of a random sample of 9th grade students from Alabama asked whether students owned a cell phone and whether they had brought a personal electronic device to use for schoolwork that day. The two-way table of row relative frequencies below shows the data. Okay, so see this total here is 1 or 100%. Okay, so these are just percentages converted to decimal. And notice the row totals, when you add them together, they add to 100%. All right, so they gave us row totals, but they did not give us column totals. You see, if you add 0.57 and 0.2, it's not going to be 100%. All right, so these are row totals only. And I'll give you a hint here for these. This problem is tricky. If you're given row totals, you cannot compare the likelihood of one row to another. Okay. See this here? This is a total percentage, okay? And this is 43% right here. It looks like this is less than this, but that's not necessarily true because this could be 43% of 100. And this could be 80% of just 10. All right, we don't know that. So if you're given the row totals, you cannot compare the likelihood of one row to another. All right, the same is true of the column totals. So whenever you get this question, it's tricky. Let's look at their answers. 57% of the students in the sample do not own a cell phone and did not bring a personal device. Okay, so here it says, do not own a cell phone and did not bring a personal device. It looks like 57% of students, right? But that's not true. This is 57% of this row right here. Okay, so this is just 57% of does not own a cell phone, not of the total. All right, they only gave us row totals. They didn't give us column totals. So answer A is incorrect. All right. So it's not going to be A. Now let's see answer B. A student who owns a cell phone is less likely to have brought a personal device than a student who does not own a cell phone. Let's see. A student who owns a cell phone, out of these right here, a student who owns a cell phone is more likely to not bring the device than someone that brought the device. Okay, so if the student owns a cell phone, he or she, in all likelihood, did not bring another device. Let me see if that's what it said. A student who owns a cell phone is less likely to have brought a personal device than a student who does not own a cell phone. Let's see. We can't compare the likelihood of, let me see. Okay, a student who owns a cell phone is less likely to have brought a personal device than a student who does not own a cell phone. Well, that's not true. If the student owns a cell phone, he is more likely to bring a personal device. So it's not B. All right. Answer C. A student who owns a cell phone is more likely to have brought a personal device than not to have brought one. Okay? A student who owns a cell phone is more likely to have brought a device than not bring a device. Is that what it said? Yes, that's correct. Answer C. All right. And just to double check, answer D. A student who did not bring a personal device is more likely to not have a cell phone than to have one. Okay. Remember, they said more likely to not have a cell phone than to have one. Well, since we have the totals for the rows, we cannot compare the likelihood of one row to another. We can't do that for answer D. Okay, so that's how we know D is not true. All right, so it is only answer C that's correct. All right, this one's tricky when you get this type of problem when it only has the row or column total. All right, so like they said for answer D, we only know the row relative frequencies, not the column, so we cannot make this claim. All right, like I said, we don't really need to go to the write-up. All right, just look at the chart. Preferred status versus pressure from homework. All right. So you can see again, we have row totals here, but not column totals. And these are percentages. All right. But the percentages in each row are percentages for that row only. They're not total percentages for the whole chart. Since we have row totals, we cannot comment on the likelihood of one row to another. So if you see any answer that says more likely to be happy, healthy, or rich, you know that's not true. All right. A student who prefers to be healthy is more likely to feel very little pressure than a student who prefers to be rich? Let's see. Student who prefers to be healthy is more likely to feel very little pressure than the person that's rich. All right? A student who prefers to be healthy is more likely to feel very little pressure than a student who prefers to be rich. That's true because this is more than this. All right, so it's answer A. You can compare the likelihood of the columns. All right, more likely to feel very little pressure. The very little pressure is right here. That's a column up and down. But you can't compare the rows because we have the row totals only. All right, so it is answer A, but I'm going to go through the other ones. A student who prefers to be happy is more likely to feel very little pressure than a lot of pressure. All right. A student who is more likely to be happy, a student who is prefers to be happy, is more likely to feel very little than a lot of pressure. Okay, we can see that's not true. Very little is 0.13, a lot is 0.46, so it's not B. A person who feels some pressure is most likely to prefer to be rich. Okay? We cannot comment on the likelihood of being rich because we have row totals. So we can't comment on the likelihood of the rows. Answer D, an equal number of students who feel a lot of pressure from homework prefer to be happy as prefer to be healthy. Well, we don't know how many students prefer to be happy, and we don't know how many prefer to be healthy. This is just 100% here. We don't know 100% of what. This could be 100% of just 10. This could be 100% of 90. Okay, so we don't know. So the only one is A. For all of these, you're choosing one answer, but I went through the other ones just in case. Okay, you don't have to do it that way. If you're sure of your answer, you can just choose it. All right, so this is about researching kiwi birds, species versus gender. Okay, and these are actual numbers here, not percentages. And you can see they give the column totals, and they give the row totals. So we can comment on basically anything they ask. Answer A, there were the most observations of female Takoka kiwis. Let me see. Female Takoka kiwis, they observed 44. Okay? So that's actually true. Out of all the observations, 44 is the greatest. This is 42, 24, 19, 39, and 32. So yes, that's the most observations. Okay, ignore the totals here. You got to cut those off and look for the most observations. So A is definitely correct. And just to show you the other ones, great spotted kiwis were more likely to be male than female. Let's see. For the great spotted kiwis, that's this column right here. Out of this column, they're most likely to be female than male. So B is incorrect. Answer C. More than half the kiwis were Northland brown kiwis. All right, let's see. For the kiwis, more than half the kiwis were Northland brown kiwis. Well, we have a total of 200 kiwis, and for Northland brown, the total is 81. 81 out of 200 is not more than half. Okay, and finally, answer D. Northland brown kiwis were more likely to be female than Takoka kiwis were. Let's see. Northland brown versus Takoka. Northland brown versus Takoka. So the probability of female for Northland brown, it's going to be 42 out of 81. And for Takoka, that's going to be 44 out of 76. Okay, let me use the calculator and get a decimal. Okay, so I did the percentages on the calculator, the probability of it being female. And you can see this fraction is 0.58. This fraction is 0.52. So the Tacoca, since 0.58 is greater than 0.52, the Tacoca is more likely to be female than the Northland Brown. Okay, so the Tacoca is more likely to be female. So D is not true either, so it's definitely A. All right, like I said, you don't have to check the other answers if you don't want to. If you're confident it's A and you don't want to check the other ones, that's fine, but I just wanted to show you.